Afternoon all, how we doing? How we doing? Just having a bit of a clean up. Lastminute.com as usual. So a bit of a clean up of the bench here. That's nice, that's nice. There we go. Right, who we got in today then? You can see my nice little on-air sign. That's Christmas present from Trev, my brother let. So we've got Timothy in. Hi Tim. Back to the 1 picofarad capacitor. Yes. Well, I bought a job lot of them. So I got, I don't know, there's about 50 in there, I think. 1 picofarads because I spent ages trying to find one of them, and we tried to make one and all sorts. For those of you that remember back to the last time we had to play with this SW55, I thought it was all done, to be fair, but I popped a new crystal in it. Well, I replaced a crystal for one in my set to try and get the frequency a bit better. It was still off frequency. Now I was able to trim it to within about 0.3 of a kilohertz, but it's still 100% right. So if you remember last time we used the Stabalok to sort the frequency out, but that little servicing tool as specified in the manual didn't work, did it? So it just didn't seem to do anything, and it was determined that it had to be in a box, it had to be screened, and I didn't have the right components, I didn't have the right resistors, I didn't have the right FET for it. There was lots of things wrong, so today hopefully I'm going to put all that right. Who else we got in there? We got Chris in. Chris Milky Eye. Chris, how are you? Matambli's in. Coffee's just brewing. Martin, how are you doing? I'll catch you later, mate. Michael Hyde. Aaron. Cold, you see. It has been cold here today. Hi, Derek. It's been sunny though, isn't it? Could snow? Yeah, it's quite possible. It was hailing yesterday. I went out to have a look to try and do something to Mrs. Cruncher's car, and started hailing on me. I do like a bit of snow. Well, we don't seem to like it on the roads though, do we? It sets us to a standstill. Any tiny bit of snow, we're at a standstill. Nick's in, thank God for that, Nick. Or kit, or what do you call it? Constructor of the year. Nick is in. So Nick will be able to advise me what I'm doing wrong on this, because I'm bound to be doing loads of stuff wrong. Hi, Mike Cass. Four degrees, fairly sunny. Well, it was 1 degree when I got up, and everything was covered in frost this morning. Hi, Tom and Susie. Snowy Mitch again. Simon sitting comfortably. Good on you, Simon. I'm Rob Titheridge. How are you? Bob Anderson's in. Hi, Bob. Brass trim polishing. Tino, how are you? John Hood, hi John. Benji's in. Rob Cross, thanks Rob for the super chat. Peter Carter, hi Peter. Anthony's in, hi Anthony. Multi's in, hi Multi. Cyber. Dave Rhodes, David Tagg. Okay, I'm nearly up with you. I'm nearly up with you. Dave Malek, hi Dave. And Mac Vision. Yeah, you are the constructor, Nick. Come on, you do like a bit of RF construction, right? And I'm sure this is an RF construction project, isn't it? So I've been messing about with this morning. I've just done a bit of prep. That's all. I've made sure I've got all the components here. I've pre-drilled the metal case. I'm going to put it all in. I've selected a bit of Vero board and I've temporarily laid it out on the track side of the board. But I think I'm going to have some capacitance issues, so I'm going to need to do a bit of trimming of the Vero board, I think. Probably not the best thing to do this on, but it is literally a postage stamp size board, so I don't think it's going to cause too much of an issue with stray capacitance, etc. Simon, how you doing, mate? You're in at last. Good to see you, mate. Hope you're well. Okay. So just to refresh your mind, this is what we're trying to create. Now, this is out of the SW55 manual. Now, this thing they call a servicing tool is in a lot. It's in a lot of the Sony manuals. I had a quick look through this morning. It's in the SW7600 manual. I think it's in the SW1 manual. It's in the SW77 manual. I think there's 5 different manuals that I found it in. So it is something that if you're working on these, I suppose, and doing any sort of servicing, really you ought to be building this little bit of kit. So hopefully if I can get it going, it should help you lot have a go yourself. Now I did have a little mess around with that drawing, as you've probably seen. I wonder if I can find it now. Is that it? I had a little mess about with it. Yeah. Okay, so I ended up with this in the end. I just cut off some of the bits and pieces, and I've put on here pretty much what I'm going to be doing. Yeah, you can see that. So this side goes to the radio. I've put BNC there, because it says on one of the other manuals that these leads need to be screened, which it doesn't say in the SW55 manual, but these leads really ought to be screened. So I'll put BNCs on there. This dotted line is obviously a box, an enclosure, and I assume this is weird because they've got these little dots joined to the box. I don't know whether that means it's insulated from the box, but I would have thought that that ground there would have been connected to the box, really. I'd assume this is got to be a metal enclosure, and that ground ought to be connected to there. So really that should be shaded black as a connection, but these shouldn't be connected to the box. Well, the grounds should be, but yeah, so really that should be a connection to the box, and that should be a connection to the box. Also, it doesn't show a negative on the 5-volt supply, but we must have to have a negative coming off of here somewhere. So really there ought to be a negative coming off and joining up for our power supply, don't there? So assuming that this negative has got to go to the probe, and we also need a negative to go out to our power supply. Otherwise it ain't going to work, because if you haven't got a negative, you're not going to get any power into the thing. So it's a little bit iffy drawn, I think, personally. I don't know what your thoughts are on that. Where's my chat? Let's get a chat up, see what you think. Constructor of the year, yeah. Aston's in as well. Hi, Aston. Simon, Finger Fund, 2004, 2024. Thank you, Simon. Needs a decoupling cap from power to earth. Not sure where you mean there, Nick. You're going to need to talk that through me in a minute. Talk that through with me in a minute. High impedance amp thingy. For more fingers, Chris. I'm going to be fingered right out, aren't I? Needs to earth the unit being tested as well. So really we need more grounds then. The box should be grounded to the power supply, doesn't it? Yeah, I see. I don't know whether I've got enough grounds unless I put a double ground coming out of here. Yeah, I'm not sure if I've got enough grounds then. The box should be grounded, yeah, definitely. But that's going to be grounded to the power supply, isn't it? So if I ground the power supply to the metal box, where am I? Yeah, I'm still on this picture. Christoph, how you doing, mate? Stick it in an Altoids tin. I've got a little enclosure here, Benji, that I've drilled out already, all ready for it. But I might need to do some modification to it. I don't know. I might need to add a second flying lead to the power supply cable, maybe. I'm not sure. But we can have a look at that as we go on. Rob, more finger. I've still got finger here, ready to go in. The BNC lead will be the ground to the counter. The BNC lead, the other side, Timothy, will be, because I'm going to use that as a ground to the radio. So I will have a ground to the radio through the BNC connector, won't I? So if I got a scope probe connected to this side, which is what I was thinking, that's going to ground the radio, isn't it? So that's going to be my ground, isn't it? Hi Lee, how are you? From the positive supply to the negative close to the FET. 10 NF would do. I mean, we've got this one here, but yeah, we're doing all right, mate. Hi, Harvey. Yeah, I'm doing all right, Christoph. Getting there, mate. Probe from the Cisco has to be grounded to the item being tested, so an active probe will be the same. Yeah, I mean, my other option is to just have a flying BNC lead here with just two connections on it to solder to the board. I was thinking maybe a scope probe connected on this side, and then the BNC on this side is obviously connected to the frequency counter. So the frequency counter, well, it's not necessarily grounded if I use my battery one. But Les, afternoon Les, how are you? Right, let's get on the bench and I'll show you what I've got so far. I'm going to say I've done some of this, but we've still got quite a lot to do, so I haven't skipped too far ahead. Don't even need a PCB. I could do it point to point, Benji, yeah. But I've just got this little tiny bit of strip board here. And I've just put the components that I need on that, and literally it can just be suspended in air. Just makes it a little bit neater than doing it point to point, really. My only concern is because this is strip board, we've got capacitance in between the strips. And if I stick a capacitance meter between the two strips, you know, there is capacitance. So I need to peel back strips that I don't need. It probably would have been better done NIC style, really, Petronic style, and just done on a flat board and just lands carved out of it. But you know, this is what I've got. So I mean, it should do it, shouldn't it? I mean, end of the day, there was issues with the previous version I did where I did it point to point wiring, in that we had the wrong components, really. I'm trying to cobble up all sorts of stuff. So this is pretty much it. As I say, I need to just break some of the track going up this way so we don't get stray capacitance. I did have one of those little drill bits that you can twiddle to do that, but can't find it now. Scope lead is bad idea, too much capacitance. Yeah, I have got some coax that I may use temporarily. The problem is I haven't got a connector. I haven't got a BNC connector that's small enough for the coax I want to use. So I'm probably going to have to buy myself a couple patch leads, I think. But just let me grab the coax a minute. I have got some small coax leads that I can use to connect to the... Oh dear. As usual, everything is attached to everything here. There we go. Yeah, so I've got some of this coax. This is really thin stuff. I can't remember the name of it now. It's RG 400 and something. I can't remember, or 2 something. My little 1 picofarad's disappearing again. So, I mean, I could just solder that to the board, put a little grommet in there, and come out with a grommet out through there. But I'd rather go with a BNC if I can. I have got some BNC leads. And I've got BNC leads in this nano VNA and various other bits of kit. I've got these little SMA connectors on them. So, you know, that would be enough to connect to my scope. Actually, no, I'd need a big BNC, wouldn't I? Not an SMA, so I need an SMA to BNC connector, and the more things you add into it, the worse it gets. So, yeah, I thought that was BNC, but it's not. So yeah, I need a connector to BNC from this thin stuff here, really. I've got some RG, what have I got? Some loads of RG stuff here that I could probably cobble up. Radio Birder, how you doing, John? Happy New Year to you as well, mate. Penguin's all right. He's back in his box, I think. I think Mrs. Cruncher's already bagged him. Too much capacitance on a scope probe. All right, Nick. Scope lead, bad idea. 3mm drill. Need plain Vero. Coax has too much capacitance. Should be as a pin as a probe. So you're saying use this thing here directly on the board, Nick? It can't be that difficult, surely. No worries, Rob. A pin probe attached directly to the BNC input. A short, solid wire. Penguin's hibernating. Yeah, he's gone back in his box. It does say on one of the service manuals that you should use coax for it. So it's conflicting info, isn't it? It does say you should use well, it says a shielded wire. So are we saying that a shielded wire and a coax are different? Should I be using audio cable? I don't know. It's this is so confusing. So you'd need a ground off of it as well, though, Nick, wouldn't you? It is Teflon coax Danish. Welcome, Paul. Well, all this talk of pins and probes is making me need some medicine. So I'm going to have to pop in the first finger of the day. Let's get back to the service manual and I'll show you then, Rob. Let's get back to the service manual. So let's zoom out a little bit on this. So this is a second local adjustment, and we're looking for 55 megs, 55.3912. So it's quite a fairly critical one. I mean, you know, it's just showing this wire going to the board. So this is how it's laid out, and we're just going down onto a test point. Hopefully you can see that, Rob. Yeah. So yeah. Well, it's the second local adjustment. I take it that's the oscillator, isn't it? Or is that the second I? And that's not a second IF, is it? No. And we need to do this one first and then go back and do the USB one, because I think messing about with this messes with the USB one as well. So it's still a lot of stuff to do. I need to have a look at the PLL adjustment as well. That's hence why I need to get the finger in me. Rolf, how you doing? No worries, Bob. It tells you in the manual what the colours are for the resistors, so you don't really need to worry too much about resistors. Cold turkey. We've had all the cold turkey, Timothy. Yeah, you can't beat a wood burner, RV. Actually looking forward to a beer today. I'm pretty thirsty. I mean, surely it shouldn't be that much of an issue at these frequencies. I can understand if we're up in the gigahertz, but surely around 55 megs is not going to be too finicky, is it? Hey, yeah, that'll be very nice, Christoph. La chuff. Yeah, really enjoyed those, and the ones that that were kindly sent over from the Netherlands. Very nice. Winding coils for square to sine wave converter. Oh, very nice, Aston. Have you got a coil winding machine as well, Aston? Just trying to get some more thing here. Yeah, so I've had my my Trappists, Martin, all done. Very nice too. I had the other one last week actually, so I did save them. Banana plug and socket, coax to the frequency counter. You're off the beer during dry January, Lee. Started a new project, Grundig tube radio. Power transformer's blown, yeah. That little one that we use is going to be no good to you for that, Christoph, is it? Doing it the hard way, flipping that. That's going to take you a while. Mind you saying that, it's probably only a small coil, isn't it? It's not like a big transformer. Yeah, so I'm doing it all the wrong way then. Auntie's just saying just use a banana plug and socket, coax to the frequency counter. I have got banana plug. So I could probably. So if you see my little box here, I am on my screen, aren't I? I've just got so many screens up here at the moment, I'm confusing myself. Yes, yeah, okay. So I've got the little box. I've drilled the hole for the power supply, the 5-volt supply. And I've drilled 2 holes for BNC, so I could stick one of these in that hole. If we think a banana plug would be better, I think that would work. So yeah, I could certainly stick a banana socket in one end. You think that would be better? Slightly too big a hole, but it's still going to be insulated because it can't touch. So I could do that. How would I get my other ground to the radio though? Do I need to drill another banana plug socket? I need to drill 4 holes in the poor thing. So any capacitance in the coax will load the oscillator and defeat the object of having a 1 picofarad input capacitor. See, this is why I asked these questions, Nick, and that's why we've got the expertise of the champion constructor of the year. Okay, that might be a little bit big for there. Does that baby spanner fit that? No. So I brought this spanner in from my toolbox thinking I'm about to fit some nuts. I've yet to find a nut that spanner fits yet. Oh dear. I chucked my spanners down here earlier. My one's from the toolkit the other year. Is that one going to fit it? No, that one maybe then. See, that doesn't even fit it. What's going on here? I've got 6 and a 7mm there, and 6mm's too small. 7mm's too big. What is going on? Use the banana for the pin probe. Yeah, Anthony. Have I missed something else? Coax to the frequency carrier. Yeah, we're going to have coax to the frequency carrier. That's not a problem. But I still need to connect a ground to the radio from this, you're saying? Do I need a ground to the radio from this? I do, don't I? That's annoying. I wonder why that doesn't fit anything, that screw, that nut. That's why it pays to have a adjustable spanner in your toolkit. I've ordered my screwdrivers for me toolkit as well. I'll start making a video on that. I'm really snowed under at the moment, so I haven't got the giveaways out yet either. But they will be coming out hopefully soon. I've got so much on, I don't know where to start really. The most important thing, I suppose, is my accounts have got to be done. Got to get them in before the end of January, otherwise they fine me God knows how much, 100 quid I think it is to start with. So potentially that could be our probe, and I could make something up. I've got some jack plugs here somewhere. Yeah, I've got some banana plugs there, look. Should go in there. So I'm just putting the little tag in there. You can see that little tag. That'll be our probe lead. But I still need a flying lead from this box to the radio under test. So I mean that's my little circuit there, and the FET has jumped out now. I believe it was something like that. I'll adjust that again in a minute though, but let's get you in a bit closer. There's literally hardly any components on this. It's that simple little thing. Where are you? Stop there. So that's the board. I've just marked out roughly where I need to cut it. As I say, I'm trying to not have a lot of stray tracks knocking about. I need to just get a knife and cut and peel back this so I've got no capacitance that way. So the probe will join in just to here on this capacitor. Now this is upside down, so I've just laid it out so I know where I've roughly got to cut it at the moment. Actually, that's not great there, is it? I need to probably jump over one because that's not a lot of a path there. Yeah, everything's going to have to jump up one by the looks of it. Let's just catch up. Now we're jumping quick now. Do you have any ring terminals you could use underneath the banana socket? Yes, Graham, I don't see a problem with ordinary BNC leads. No, I didn't think so, Rob, but BNC would be nicer. There's nothing to stop me making a BNC pin probe, is there really? That would at least give me my ground then. Because if I use a BNC, I've already got the ground, you see. The ground is on that tab there, and the positive's there. So the BNC would be better. Then I'd just have to have a BNC lead to a straight wire, wouldn't I? And then I'd be able to connect my earth to the BNC as well. I can make up my own lead for that. Let's have a look. Let's get a BNC plug a minute. If I've got a BNC plug, that's a crimp one. I haven't got. See, that's probably the right size, isn't it? No, I don't know. I haven't got any crimping pliers for coax or anything, but I want a BNC plug now, don't I? There we go. That's just a normal one designed for coax, but I can easily just run wires out of that, can I? I think. It's going to be difficult, isn't it? It's going to be a pain in the backside whichever way I do it. Welcome back, Rob. Hopefully you had a nice lunch. Okay. I understand you, Derek. Interesting stuff. Monkey wrench gang. Never ever used an adjustable on a car. Afternoon, Robert Head. How are you? See, I made up an RF probe ages ago. That would probably be fine, wouldn't it? I made one of those that fitted a multimeter many years ago. So I'm just trying to think how this would work. Let's see. Just how I could connect to ground, because normally the ground is just squashed in these things. You just squash a bit of coax in there. So that's my pin. Just trying to get my head around this a minute. So that'll be my pin there. But what holds that in? It's held in by the coax, isn't it, normally? So if I'm not using coax, I've got nothing to hold this connector in, have I? Haven't got any other types of BNC connectors? I don't know. Yeah, Nick and Derek are in charge. Nick, Derek and Anthony's in there as well. We're all having an input. This is what it's all about, isn't it? Getting the input. Just trying to think how on earth else I can do this without using a bit of coax. Because that's a normal BNC connector. I've got a fancy one there, but it's still Actually, has that got a captive? If that's got a captive, that's a fancy one, that is. It's one of those nickel silver ones. I tend to pick these up from radio rallies. They've even got a right angle one there. So yeah, these are nickel silver. They're like a dull silvery colour. I think they're green par, is it? But it looks like these have got a captive pin in them, not a loose pin. So I might be able to wangle one of these a bit easier. I've got an angled one there. I don't think this is going to be any good, this particular one, because of the fact that the pin is not, you know, the pin's movable, and the coax is what holds the pin in. And because we've got not going to be using coax, I've got nothing to hold the pin in, so that one unfortunately is going to be a no-go. I could botch it up, I suppose, but I don't want to botch it if I can help it. So let's try and do it proper. So I prefer to use the BNC leads if I can. So this one here, which is an angled one, and it's a slightly different connection on this angled one. The pin is already in situ. Yeah, that would potentially be better. Then I could probably trap a ground wire in here somewhere. It's got a little tiny screw hole there. So if we unscrew that, a big screwdriver. I've got a little. Okay, yeah, so there's my pin. So just solder the wire into that, and that little holder there holds the wire in. Camera's having trouble focusing on this, isn't it? So yeah, that little beast there is where you'd solder your wire to. Got a little instruction book here. That. I mean, I could, in theory, still use a bit of coax, couldn't I? I mean, I could just use the coax, strip it right back. Just strip the braid out and use the inside piece as my probe, couldn't I? In theory. If I just strip it right out, I could use the braid as my ground. I'm just thinking. Cigar tube. Mike Cass, thank you, Mike. Metal tube with a pin sticking out. A metal tube with a pin sticking out, Nick. So you mean build it into a metal tube? Sandra, how you doing? No worries. Yeah, got no metal tubes here. Lots of cardboard tubes and plastic tubes, but no metal. This is how we're going to do it, Nick. We're going to have to do it with this. I've got no other answers. I have no other solutions. So how on earth are you going to solder that? I'm just trying to work out how on earth I'm going to solder that. So I think that's got to come out. That's a pin on. I can't solder that back on. What's that? That piece of PTFE there goes back in. So I'll have to solder it like that. Yeah. So I'm just thinking if I was to connect that in there, strip the braid back. I don't know if that's a solid center or not. Let's have a quick look. See what the center is on this thing. Okay, it's not solid center, it's yeah, it's not a solid center. I mean, solid is that cheap stuff usually uses a solid center connector, doesn't it? What have I got over here? I think this is 75 ohm coax over here. Yeah, 75 ohm. It's typical. Whenever you want stuff, you can't find it. Belkin. No, that's 4-core. Yeah, I'm just thinking if I was to strip this back. Don't think I'm going to be able to pull this off here. Cool, it's damn hard stuff that. I've got a bit of Ferrari in here to fix as well. Interesting. See if I can get that out on Patreon and channel membership in the week. Yeah, I've got a fuse box for a Ferrari in here at the moment to fix. I get some weird stuff in here, don't I? Ben, how you doing, mate? God, this won't come off. I'm trying to separate the braid without breaking it, because I could use the braid, would make a very nice ground tag. Put a little clip on the end and that would be very nice. It's not going to let me, is it? I'm going to have to cut it down. Oh, you haven't got the caps lock on again, Rob, have you? What does he do? Let's have a look. Yes, he got the caps lock on. Dear, oh dear. He's the caps lock king, Rob. The king of the caps lock. Yeah, it's going to be nigh impossible to strip this back, isn't it? Yeah, that's that out the window. What next then? What have we got? We've got some solid red wire here. No, that's not solid, that's stranded. I've got some solid copper wire here somewhere, but surely that's going to pick up stray signals, etc. etc. Another wire have I got here? Got twin and earth. Well, no, I've got 2 core. Got some more cloth coated. You got some speaker wire. Got some ground earth cable. Everything bar what I'm looking for, as usual. Oh dear. Gia, how you doing, mate? Remember to do the thumbs up. Don't forget the thumbs up, people. Don't seem to be getting anywhere fast here. I'm still trying to find some solid wire. Can use braided, I suppose, for the ground, but it'd be nice to have a solid wire, I suppose, for the centerpiece. Probably not essential, but I really don't know. I really need to get to grips with my wire situation here. I need to make up some racks for wire. Wires all over the shop in here. I don't know which is. Oh, now that is definitely solid. That is definitely solid. That's single core solid white wire. So let's start. We're going to have to start constructing this, otherwise we're never going to finish. We're never going to finish if we don't start soon. So let's do our board first. So every component's got to move over one. It's got to move over. That one's got to move over. Took me a while to work all this out this morning. Now I've got to pull it all apart again because I didn't do it properly. Let's just pull them all out. Let's pull them all out and start again. The problem is I've got very little on there. Right, okay, so that's going to be my first one. And I'm going to be breaking it here. So my brake line needs to be down through there. So I should be able to break it there, yes. And I'm going to go with my original plan. Take that down one notch, make it a bit sturdier. There. So what I'm doing is using the knife to cut through the tracks and into the fiberglass slightly. Then it should break cleanly. There we are. So that's my circuit board. Don't really need to tidy it up. End of the day, it's going to be hidden away. Get rid of my black mark on it. Okay, so we're going to stick our little tiny 1 picofarad cap in there, and that's going to be where the scope, where the probe is connected to. So let's get our diagram up. So I got my diagram printed out, good to go. Harvey, how you doing, mate? Other Harvey. Massive aluminium box. I know the feeling. You just got to go with what you got, haven't you, half the time? Right, so we've got 1 picofarad, then off of that comes our 1 meg resistor. So a 1 meg resistor joins in there. And that goes to ground. So that's going to be our ground there. So then we've also got the gate of this one, which is the middle, I believe. That's got to connect into that one. No, hang on, the source has got to connect to ground. This is why I had all this laid out really nicely. Let me zoom you in a bit so you can see what I'm up to. So this is our little tiny FET, the 2SK193. So we've got gate, source and drain, but I can't remember which pin's which. I think the center one's a source, but let me just get that back up again. I did look it up earlier, but let's look it up again. I didn't think I'd need to get it again, but I do now. So the pin out is gate, source, drain. Middle one being source, first one being gate. So gate, source, drain. So source has got to go to there. The source goes to ground there, and that one's going to go up there. Okay. So let's lock those legs in before they jump around again and I get confused. It's not, I'm easily confused. Right, let's just stop them all jumping out now. So we've got gate is joining to there, yeah. That's all 3 connections to the gate, which is the capacitor, resistor, and the gate. Oh, hang on. Gate, no, that's wrong. That's wrong. Oh dear. See, I'm not constructor of the year. That's Nick, not me. Right, let's try that again. So we need the gate to there. Source to ground. It's lucky I was watching the chat. Yeah, my battery pack's run down again. That's strange because it is showing it's got one light on it, so it's not actually empty. Strange. Yeah, it just decided to shut off. Alright, let's leave that connected. Luckily I had this one on charge earlier. Hopefully we're back now. Yeah, we're back. Audio, sound gone, sound gone. Yeah. What are you guessing, Peter? Silent movies. I think we're back anyway. Dids, yeah. Fingers going in, mate. It's here. Here. It's going in as we speak. I'm just going in gently. It's going in gently. Right, what was I doing? I've got a massive great soldering iron tip on. Can't remember what I was soldering up with that. Right, so let me just connect these up a minute. That's not what I do, is it? Oh, you damn thing. I have got a third hand tool, but I need to 3D print another ball socket for it. And that's going to collapse on me if I try and pull that down. Let's just clip the forceps to it. That should hold it in place a bit better. Come on, you flipping thing. I was hoping to have this done by now. Come on, solder. Thank you. Right, capacitor and resistor are in. Let's cut the legs off of them. Probably end up having to redo all this in a minute. So we're going to use a little bit of this wire here. So output to the probe, whatever that's going to be. Stay still, you stupid thing. Right, that's going to be my output to my BNC lead connector even. So I don't need any of that track in there now at all. So the gate has got to go in there next. Pardon me, so that's the gate, that's got to join that connection there. So I think I'm just going to go with it. Gate. Source is going to ground, same as that one. Okay, so already this is evolving. Put that over one. There. I'm just going to double check that again. Yeah, gate, source and drain. Gate, source, drain. Connect that up. Stay there. Let's get my eyes on, I can't see what's going on here. So that's that. So this is all ground in the center. Right. That's the story so far then. Where are we? So that's our input coming in via that cap onto that resistor and the gate of the FET. Source is grounded, the other side of that resistor, and this other lead here is going off to the 5-volt source and the BNC input. So from there we need our 2.4K. This has certainly gone a bit different than it was how I laid it out earlier. I laid it out really nice earlier. It's sort of like a bright pig's ear now. That's one side of our resistor. Now that resistor's got to go to our 5-volt out, so I think I'm going to stick that away from there. So let's use, I only need one pin for the 5-volt rail. So let's go. Let's use that one next to it. It's a 5-volt. Hang on, no, that's wrong. You get confused which way the tracks are running on the other side of this. Oh, I forcepped my finger up then. Right, okay. That's our 5-volt rail. That's the 5-volt rail. That's our 5-volt rail. Let's cut a little bit of wire for that. Okay, so if that's going to there, that one ideally ought to come out there. Let's pop that one in there. You call it a damn pain in the backside is what you call it, I think. Okay, so that's our 5-volt, that's our input. 5-volt input. So our ground is there. I'm sure I had some black wire flying around here somewhere just now. Whew. Right. Yeah, Aaron's the same. Right, let's find some black wire, just so as I know where the hell I am with this. If I put any other colour wire in, I'll probably connect it wrong. That's solid wire, let's put the same in. Got some braided wire somewhere, not braided, stranded even. I think my brain's stranded. The brain is still stranded in Christmas, I think. I definitely had some stranded black here because I've used some. Yeah, my wire pile here is a right mess. It is a right mess. I need some cable management. So anybody got any cable management ideas, then hit me up. Because I'm struggling with cable here. It's all getting tangled up. This is a problem. The more I pull it about, the more tangled it gets. I definitely had some. I haven't now. So the ground will be solid, it doesn't matter. It's not going to see any current, this, very little. I definitely did have some stranded here somewhere. Let's pop the ground in so I know where the ground goes. I'm probably going to need more than one ground, I expect. But I'm going to use that as a ground to my power supply anyway. So I'm probably going to need another ground in there to the actual chassis of this to take the BNC grounds out. Right, where are we from here then? So I've got the 2.4K resistor in line with the 5-volt supply. That's done. So I've only got this one here left to do now, the 0.01 microfarad, and that goes out to the BNC to the frequency counter, center pin. So 0.01, which I've chosen this one here. That's the first thing that I found, which was a 0.01. 102, I should make sure that is definitely a 0.01. Oh, that's 0.001 or 102. Flipping heck. Just as well I check that one out. 0.001. So 0.01 I need, which is 10 NF. Which is there. Seems a bit big for 10 NF. Only need a little piddly ceramic, don't I? I don't need anything fancy for 10 NF. Let's get the old Velleman ceramic capacitor set out. Sure got 10 NF in here, 103. Probably the most popular one that I've used, I suppose. In fact, they're probably so popular, they're probably not even in here. 102. 101, 104, 223, 221, 10, 10, 103, there we go. Yeah, in fact, I've only got that many left, look, so that's the most popular one in the village. Let's get some more 103 ceramics, won't I? Not bad little kit that, it's got quite a few in it, look. I'll say it's not something you use very often, but it's 224 Velleman. I'll see if I can put a link in the description. Just as well I check that though, because that would be another thing that was going to go wrong, wouldn't it? Right, okay. Where does this one go then? This one goes in series with that, on the base of that one. Now, which way is it going? So I'm going to need to go from there to there. So go from there to there. I'm going to check all this afterwards, so don't worry about that. I'm also going to remove any of the traces that I don't actually physically need here, because otherwise we're going to end up with lots of capacitance flying around. It doesn't matter too much. Right, so that goes out to my BNC, my output BNC. So it looks like everything is connected to the same ground. So I don't think there'll be any issues with that, will there? Although Nick was saying about the 10 NF from the ground. They're moving along gradually. That's all of our components on. 1, 2, 3, 4, 5 components. 1, 2, 3, 4, 5 components. Yes. So we've got our power supply and ground. We've got our input, BNC input, I think we're going to go with still. We're going to need another ground, unless I just ground the chassis. I only need to ground that chassis once, don't I? I don't need multiple grounds on it, do I? Let's take that one back out then. The prisoner. So I'm going to get rid of the probe idea, and we're going to go with a BNC socket, as I was originally. This would have worked, but I'd have had to put a separate one in for the ground. So I've ended up drilling another hole in yet another connector. It just cuts down the hassle. So let's stick the BNC in there, wherever it is. Let's be on the BNC. Let's have a look then. So that's going to be my positive, negative. That's going to be that BNC there. So I think we'll go, shortest route is going to be there. So it goes tag. No, it doesn't. It goes lock washer. I think it's lock washer first, isn't it? Then tag. If you can see what I'm doing, it's difficult to sort of watch the cameras at the same time here. I've got my great thick fingers in the way, am I? I wonder if we've got the right size spanner for that one. What do you reckon? Nope. Nope. The last one? No. What is it with these nut sizes? I've got 12 and 13 there. I mean, 13 fits it, but not great. Was it just these weird spanners? No, it's bigger than 13, see? Sorry, smaller than 13, but bigger than 12. It's like 12.5 mil. They're still using imperial sizes for the nuts on these things. This wants to be a really tight as well. I don't want to chew up the BNC if I can help it. There, that's pretty tight. So we've got a ground lug there. So I mean that's making a good ground into the chassis, and I've got a ground lug there I can connect into the board. And that'll connect the other BNC as well. So I don't really need two grounds onto the board, will I? Let me have a think then. So probably better off next to connect our power jack up. That's going to be a nice short lead there. Lost in space. The metric crescent wrench, yeah. Fits all. So I was thinking originally to just put a big blob of what's it on there. So let me look at the ground. We've got a ground there, so that one really needs to have another one. So let's pop another ground on. Gotta make sure I've got all the soldering done before I finalise this, otherwise I'll end up in all sorts of trouble. That's a bit blobby, and it looks like I've just bridged that track. Great. Oh, even better. Massive bridge. Where's my eyes gone? I can't see what I'm up to here. Yeah, that's bridge free now. So that. So I need another wire for this one. This one even. Try not to put too much pressure on the pliers, so I don't want to squash the BNC fitting in, but I do want to make sure it's tight. There we go. So I mean, if I connect my ground to this lug, I don't need to connect to this lug as well, but I've left it in there just in case. So that's my two BNCs. That'll be my input, that'll be my output. So that'll connect in like that. So the input wants to be as short as possible, we said, didn't we? So comes off of that 0.1. So it's going to be there. If you're not confused already, then brilliant. Tell me what the hell I'm up to, because I don't know here. It's getting beyond now. Right, so that's connecting to that cap there. Okay, so I've got power, positive and negative. I've got my input and also the ground onto this board. And I've got my output to the thingamajigger there. Hopefully that's enough now. I can start constructing. Got dry joint already. That's where I desoldered that bit. Better, right, okay. Don't really want them to cross over, so I might bring that tag around the other way. If I get the thing undone again. Yeah, it just saves the two crossing over, really. Let's bring that round that side. I've probably been extra fussy for absolutely no reason as usual, but you know, that's what I do. Yes, right. Better. So they go out through there. Let's connect them onto my power supply. I'm going to use center pin positive on this. I don't need to use the switch, so I'm just using that. As soon as it goes in, that should make there. Just double check that. Ground, and that should be the positive, hopefully. Yeah, so it's those two and ignore that one. So it's going to be sat over there, so let's just cut this like and string it over the top a little bit. Some positive. Don't forget the 10 NF supply decoupling. Yeah, I'm not sure where to put that in, Timothy. Where are we saying that's got to go? On the positive or the negative? I think you said that was on the ground, didn't you? Or are we going across? What did I do with my capacitors? Another 103. So we've got a 10 NF here. I mean, it's not showing on this diagram, so why am I putting it in? I'm a bit confused now. This is obviously what I'm doing. I'm trying to. Between the positive and the ground. So I need to come off of the positive across to this ground here somewhere, yeah? If that'll let me mark it up or not, will it? No. I mean, is this what you mean? So going from this ground, I need a decoupling cap there, is what you're saying, is it? It's a bit of a rough drawing because I'm trying to draw it with a mouse. It's not great. Ha. So between the 2K and the ground. pretty much where I've got it, but joining up here. So really sort of in here. So down there. So why haven't they got it on this diagram then? If that's the case, what's going on? Why do I need this? Someone explain why I need this. That's good practice. So as near to the source lead as possible. So it's near to the transistor ground. Well, I can't get anywhere near it because I've got too much other stuff here. The closest I can get is there, unless I pop that one there out. I could, to be fair, I could even stick it in the same hole. I mean, I'll probably get two through the same one here. See if I can do that in a minute. It's for RF decoupling of the power lead. I could do the underside of the board. Yeah, I could do the underside of the board, I suppose. Wouldn't hurt, would it? It's not going to look pretty. But here goes. You can't see what I'm doing. I'll show you what I've done when I've done it here. But I'm basically going to do it as I've got it there, really. If I do it on the underside, I've got a bit more room if it'll take. Actually, it won't. Ow, that's hot. Well, that's as close as I'm going to get it. So I've stuck it on the underside of the board. Where are we? Closest, going to focus now. You probably can't see that, but so this is my positive here, and the transistor is up here. So that was just tacked onto that track just underneath the transistor or the FET, and that one's on the positive supply. So is that okay? Are we good to go? It's not going to short to anything because it's miles off the board. You can see it's not going to short. It'd be good to test it before using on the radio. Thank you, Nick. Looks pretty. So how the hell are we going to test it before we put it on the radio then? What's likely to, what am I looking for by testing it? And how do we test it is another question. So I'm just going to connect this power supply up now. Oh, hello. I've dropped me soldering tip in deep somewhere, so let's get another one. Soldering iron tip came clean off. Looks beautiful. Yes. The constructor of the year gave it the thumbs up. Derek seconded it. Oh, hang on. Flipping it. Look at that. What have you done now, Graham? You haven't put it through the hole. Look. I haven't put it through the hole. I had it through the hole. In fact, I've lost my ground wire as well, look. Oh, things are going amiss now. Things are really starting to go pear-shaped now. Right, I've got the ground wire back, but I've connected that up before putting it through the hole. So I'm going to have to pull that back out, if it will let me. Come on. It's got to go through the hole first. Right. Keep your patience, Graham. Keep your patience. It's not gone out the window yet. Nearly, though. I've filled up the hole with solder now. There we go. Back in the room. Why is this so damn fiddly? See, that fit perfectly just now, but now it won't go in. Oh dear. So Cruncher's not feeling too well today, so went up through the hole just now. I can't understand this. It's just got a little tiny bit of solder on it and it won't go back through the hole. Oh. Let's pull it off and start again. Right, that's now connected. Let's get the other wire out and connect it on. And that was to this one. Hopefully this will be like the old, what's his name? Oh, hang on. You idiot. I did have it the right way around. I had it the right way around to start with. Oh no. Oh no. Help. Help me, it's all going wrong. That screws in from the inside. Let's screw the damn thing in first. I'm gonna stop. No, I'm not going to start swearing, but it's tempting. It is tempting. Right, and I did select 2 screws especially for this job. So I'm going to screw this thing in. I can't get confused again then, can I? Thanks. Afternoon, Jess. You know, I'm making a little bit of sort of test equipment, really, I suppose. They call it a servicing tool, Jess. It's more of a pain in the blimmin' backside tool, I think. Will it ever work? I don't know. Now, because I've got its center pin, where's my lead gone now? Because I've got its center pin positive, it doesn't matter if this touches on the way in. That is a little bit tight that way around though. Would like a bit more of a gap on it, so let's just turn it the other way around. No, I think I just need to take a little bit more off of this side. So you can take a little bit more material for that side. So when the drill went through, it didn't really create a very nice hole. Not very round, if you know what I mean. I found my round file as well. I'm just showing off I got my round file back again now. Well, it's a bit of a pig's ear still, but let's make it look a bit prettier. Right. Well, I'm not arsing about with it anymore. That's got to be it now. Better. I'd probably rather have a bigger drill bit go through it, but yeah, that's better. Look at that. We have power. Right. I'm going to connect these damn knees back up again now. For the third time, because I actually had it right the first time. So negative goes in that. Positive hopefully goes in there, but it's not looking good at the moment. Let's put a bit of heat on that. Come on, you went in there just now. Thank you. Right. Positive and negative connected. So I'm going to push the board down there. Yeah, I suspect you're right, Thomas. I was thinking when I was looking at this earlier that I'm sure there's something somewhere that will do exactly the same job. Right, time to get the eyes on again. I'm going to connect that BNC up now. I mean, who would do this live? You've got to be mad at me, really. But you know, I knew you'd love to have a sing along with me. Play along with Cruncher. So I've kept that purposely short. Just wondering if that's let go slightly underneath there. Just heat that up underneath. That's better. So I'm just connecting the solder tag to the ground lug. Making sure that's totally got it, because that's a big old ground plane, that. Yeah, got it. So that's the story so far. I don't like that these are crossed. I might undo these and wiggle them back round the other way now. So I'm going to do that in a minute, because I'm a fussy git. Now I've opened up that connector hole. It doesn't really matter which way around it goes now. I don't like the wires being crossed. Doesn't look very good. There we go. That looks better. I'll be selling these for £50 each on eBay in kit form. You build your own. It's great that I didn't have a single spanner that fitted though, wasn't it? Amazing. Okay. Now this is our... See, it's still a little bit wibbly wobbly there. I thought it'd be a little bit more solid than that. Might stick a little bit of foam underneath that. Let me see if I can find a bit of foam to go underneath that, or fairly solid foam. Oh. can't reach any flipping thing in this workshop. I don't think this is conductive, this stuff. Hopefully it's not. It's black. How can I tell if it's conductive? Is there any resistance on it? No. So I'm just going to cut a little square of this and shove underneath it. It might be a little bit high, that's the only thing. There. No, it's too high. Okay, I need to shave that a bit. It's too deep, that. Just shave that a little bit. It's only just a precaution to stop it shorting on anything. I could sort of hot glue it down, I suppose, but there we are. Conductive foam. There is such a thing though, Harvey, isn't there? I'm sure there is. Don't be nasty though. I'm thinking of conductive pads maybe, but what's the stuff they put in ESD components then? Static sensitive components, don't they put a grounding thing on there? Well, I think that's it. Apart from a bit of labelling. So that's my connection to my frequency counter. That's my connection to the radio. Obviously that's my power. Shall I pot it as well? Hi Joe, how are you? Happy New Year to you as well, Joe. I don't have it. I don't have it. That's good. Because it always worries you. It's black, you know. You think, wow, what is that? I don't know where I got this from, you see. Came in just a job lot of stuff from an electronics place. But I've just checked and it's not conductive. But some of the things they put the little static sensitive things. I mean, you get these things come on this foam. That's what I was thinking, Harvey. That was my thinking. but that ain't going anywhere. So next thing is how to test then. So Nick is saying to connect it to the signal generator, Nick. Whatever next. Connect it to the signal generator. Obviously you've got a power supply. We know it's center pin positive. It needs to be 5 volts. So there's our power supply. It's not turned on at the moment. Slam the lid on before it escapes. Harvey! Contain yourself, Harvey. Right, I've got some screws. Let's be screws. I suppose you ought to keep the lid off of it for a minute just to see if there's any smoke escapes. We've got the lid on it, we won't be able to see that, will we? We won't be able to see the magic smoke escaping. Let me have a tidy up then first, because I can't see the lid at the moment because I'm so much mess on the bench here. It's a sticky pad just dropped on me there. Where did that come from? Someone's just thrown a sticky pad at me, look. Dear, oh dear, right. Simap, how you doing? Put me banana plugs away. We're doing any banana in today now. Banana plugs are off the menu. I've still got to do my little BNC probe, haven't I? Forgot to do that, didn't I, Graham? Yes, you did. Let's do that a minute. No lid still. No lids appeared so far. It's still early days. It could appear any minute. I'll tell you what, it's so frustrating with this room in such a mess. I just need to take some time out and get it done, really. Just haven't got any. There is no time. Right. Pliers. Right, and I was going to try and use that braid, wasn't I? But that was a bit of a no-go. So just saying, pop a little croc clip on the end. I think we need something with a point on it in order to get on that board. I did have an old probe lead with some wire still attached to it, a red one that I'd pulled off of something. Bet your life I won't be able to find that now. What have we got here? No, that's mains thingy jiggery doodad day thing. Now I've just pulled a load more stuff off the top just for good measure. Well, let's just connect this in for a minute. You've been watching the FA Cup as well as me fiddling with this. It's been a bit of a fiddle. It's been a bit of a fiddle. Right, so that has got to go down through there and solder onto that. Solder into the centre there. It's not going to stay there, is it? Perhaps if I put a little bend that way in it, it might. No, probably not. That's looking like it's going to stay there. Is my soldering iron tip too big to get down the hole? Probably. Wow. So I'm now connected into that center hole, center pin of that BNC. So let's put the little spacery doodad in there. Put the cap back on the top of it. That's right. Okay, so that's going to be my signal. We don't want this very long, but I'm just going to cut it there for a minute. So I've got to work out how to get the ground connected to this body next. So it looks like that goes down there, like that. Then that. Is there not another washer? I could just connect a ground. I could just rough that up and connect a ground onto there, couldn't I? Oh, that's going to be a tight fit. But how are you supposed to connect the ground to that then? Oh, I see. Yeah, okay. So that's the ground connects onto this. So I could, in theory, solder a ground to that, couldn't I? Let's do that. Let's do that. I know what I'm thinking, so just bear with me. That's going to heat sink that, isn't it? So what I'm trying to do is I'm going to try and tin this little washer. Tinned it too much, Graham. Tin the outside. I don't want to tin the outside. I have tinned it, but I don't want this bit on here. Oh dear. The more you mess with stuff, the worse it gets, isn't it? Okay, so I've tinned the edge there. So what I want to do is just connect a bit of this black wire onto that. This might not work, so you know, but you just have to humour me. If you're shouting at the screen, I can't see it. Okay, so I have a plan, but whether it'll work or not is another thing, isn't it? Actually, I can probably go straight down through that. Connect on, that goes in there though, doesn't it? No. Okay, so now I have got to go to there. I'm just thinking out loud, so got another beer to go in shortly, so I'll be fine then. Come on. Oh, it's getting hot. Set. Thank you. So I need that one on and that one on. That'll go down this, hang on, that's got to go through there as well, isn't it? So it's going to cause a little tiny bit of capacitance just there, but it's insulated, so it should be fine. Hang on though, how is that going to touch? That's not going to ground anything, is it? Or is there a ground in there? I don't think that's going to ground it. Doesn't look like it's going to ground it. Let's try and see. I don't think that's going to ground it. But you know, we're getting there. Let's do it up tight and see if that makes an electrical connection between there and that casing. I don't think it will, to be fair, but it was a good effort. I'm gonna have to solder it to the body, I think. Oh, it is. It is. Look at that. It is grounded to it. Dead short. Let's make sure we've got no connection between there and there. No, nothing. Wow, what do you know? So there we have it. That's me. That's me doodadaing, probing thing. Let's get some more tools off the bench. More rubbish out the way. I've got to find a BNC lead. There's plenty of BNC stuff knocking about. What's that? No, that's not BNC, that's an F-type. Old biro pens with a bit of stiff copper. You'd stick a PP3 inside and a switch outside, but you like separate devices. Yeah, this has got to be powered by 5 volts though. I suppose you could drop the voltage, couldn't you? Using some resistors perhaps, or a regulator. Right, let's find my BNC lead next then. That's the next thing. I have got 2 here. But any idea where? If anyone can see them, just shout quick. See, we're connected to the back there, but I pinched it for something else, didn't I? There we go. Right, there's one BNC lead. So that's potentially to my frequency counter, which I think, let's try to drop down the back here. Yes, it's trying. So that's my frequency counter. So you're saying connect this side to the signal generator, Nick, aren't you? Let's zoom back out a bit now. I think we've been in close enough for long enough. See, there's more wire arrived there, look. That can go back there, that goes in there. Still tidying up, people, still tidying up. So we can put a really, really low level signal in, I suppose. Well, I haven't got that low level of signal coming out this thing. So I've got a lead I can connect there onto my signal generator. Could do, but then you've got the problem with it being a switch mode, whether that would introduce any noise into it. Aaron, I'm not sure. So if we stick the stabber lock in, what's the smallest I can get there? 1 microvolt. 0.12 microvolts is the lowest I can go. So let's put in 55 megs, shall we? I take it this is, I'm doing this right. Where's Nick gone now? He's the one that was saying about checking it with the SIG-gen. Let me just go back to that thing and see what frequency it's supposed to be looking for. 55.3912. It will do that frequency. low, Nick. It's a buffer and not an amplifier. So what? When you say too low, you mean the signal's too low? What signal strength do I need to put into it then? Oh, it's a buffer, not an amplifier. Okay. Well, of course, increase the it's a buffer, not now. I thought it was a little amplifier, Nick. So you've thrown that theory on its head, haven't you? Well, let's put some power on and see if it goes bang. It's not gone into current limit. That's one good thing. Okay, so let's pop the filter on it. So it's sort of showing a thing, but you reckon I need to increase the output? Millivolts. Oh wow. Let's go up then. So let's go 1 millivolt. Maybe take the filter off, perhaps. Scrambling. Oh, hang on, the ground's not connected. Two or 3 volt signal. So what do I need to go, like 10 millivolts then? 20 millivolts? Really? Okay, 10 millivolts, 20 millivolts has killed it, I think. 10 millivolts. It doesn't seem to be doing a lot, does it? As I touch it. Turn the filter off. Click that to there, maybe. No. Better to look on a scope. I'll have to uncover the scope now then, Nick. Better to look on a scope than the frequency counter. The whole object is you connect it to a frequency counter though, isn't it? Okay, let's turn that off a minute. Let's pop the power off. Let's get the oscilloscope out then. Let's undo the cascade of test instruments that came down when I pulled out the frequency counter. Oh, and I've run over something else. Yes, the test lead. The national test lead stash just came crashing down. I must have a go at printing Manuel's very nice test lead thing when I get my printer up and running. Right, that's connected. That's connected there. Oops. The lead there. I'm just going to plug my oscilloscope in then. If I can find the plug. There it is. Let's disconnect that one, we don't need that. Oh, just wrenched it off the table now. So let's connect this up to the oscilloscope then. Let's put the power back on. Let's put the signal back on. No, we've got no frequency there. Hang on a minute. Yeah, that's right. I am connected up the right way. Why is not right here? Well, it is sort of trying. It is sort of trying. And we're going to do this then. Are we going to incorporate that? Will that get over there? Or is that too close? Where's the webcam? No, that's not the webcam. Where's the webcam gone? There. It's not even in focus. It's too close, Graham, too close. That's not a sine wave to me, that's shocking. I mean, it's showing a frequency of, it's jumping around, 55 point. I mean, how much higher can I go in amplitude? So 60 millivolts there now. It's jumping all over the shop, isn't it? But it is reading 55.39. Is that because I'm just not triggering it properly? That's me trigger. Hang on a second. Let me play with me trigger here a minute. Are we not triggering properly? Where's my trigger gone? What are you doing down there? Where's the trigger gone? Let's just go auto set and see what happens. I mean, there's no way you could trim that. I mean, I could go higher, but okay, it's getting a bit more stable. But I'm 90 millivolts. Surely not. Surely not 90 millivolts. Hi, Ganesh. Oh, too much noise in the workshop and the input lead's too long. Yeah, true, the input lead is pretty long. Oh, what a pain. So let's go back to 10 millivolts a minute. Let's see if I can make the leads shorter than if I put the thing directly into the center of the BNC over here. Should have enough lead to do that. So put that one directly into the center. I'm likely to get RF off of that, am I? I'm trying to connect it over here somehow. How else can I do it? All the grounds should be connected together on that, shouldn't they? Can I pop it in there? In there, perhaps? Can I squeeze it in there? That might do it. Okay. Right, let's try that then next. So I'm right up next to the SIGGEN now. So let's start popping the... Still too much noise, isn't there? I'm going to shorten the lead still further. It's not really achieving what I was expecting though. You know, you think if Sony are going to include this as the tool that you need to do this job. That's as close as I can get it, really, unless I cut the wire length right down, but then I'm going to have to resolder it then. And I'm on 78 millivolts. That's way too much, the signal, isn't it? I'm going to go up to 100 millivolts, this one. That's as high as it'll go, that. Yeah, I don't know. What's the conclusion? It's no worky, or I'm doing something wrong. What's going on? If you short the input to ground, does a signal? It's not worth checking the SIGGEN output directly on the scope. Just as a sanity check, can do that. Let's take that down, say let's go to 1 millivolt. Yeah, see this, even the, where's the webcam gone? Why have I got the wrong button for the webcam on here? Which light is blowing this one out? It's that one there. Let's turn that light off a minute. So that's the output from the SIGGEN. This doesn't sound very good, does it? Let's try it into 50 ohms. So it's jumping all over the shop there. That's 4 microvolts. Sorry, millivolts. Trigger menu won't get off now. Get off. Thank you. Ah, it's all over the shop, isn't it? Is that the lead? Is it because I've just got a BNC to BNC? Oh, I changed the probe to 1 times, but that's not really gonna. Seems to be varying, doesn't it? For some reason. Oh, let's change the. Something doesn't seem to be triggering properly, does it? Still not great, is it? Something not right with that. Bad lead? Duff cable. It could be a duff cable. Somewhere I have got another BNC connector, but I don't know where. See if I can find it. No, that's just BNC to crock clips. That ain't no good. Yeah. This ain't looking so good, is it? I'm really not sure what the hell's going on here now. What we're trying to do is make up their little probe. Their little box of tricks, which I think I have made. I think I've done it right. I don't think there's any issues with it. But somewhere I've got a nice, very nice BNC lead. 5 million foot long. That I did have connected in the back here, but then I got that other one from a radio rally and stuck it in. And I don't know what I've done with the other lead now. Is that it there? No, that's my aerial from outside. It is a big lead though, so it's easily confused with that aerial. No. I think we're close to calling this a bit of a fail, you know. I don't think we've gained anything by doing any of this. I haven't got another BNC lead, unfortunately. No more BMC. Are you giving the correct frequency input to the box? Yeah, I'm doing the frequency as it specifies in here. I'm putting 55.3912 into it. Or am I... Should I be sticking 150 kilohertz AM in it? I don't know. I mean, I can't see there's being too much wrong with that lead. It looks fine to me. Let me just check the resistance of it a minute. Let's just check the resistance of this lead. Even the computer's flickering now. Everything's flickering. Okay. Let's null this out first a minute. Right. Ground to ground. Is the ground connected between the two? Well, it's got about 0.8 of an ohm. It's a fairly long cable, right, center pin. If I can get the probes on it properly. I mean, that's 0.1, if that. If I just put this properly on the table a minute. Yeah, there doesn't appear to be anything wrong with that lead whatsoever. Pins look okay. There's nothing wrong with that lead as far as I can see. Yeah, what are we on now? Sharpie, how you doing? David, how are you, mate? Hi, Martin. Get a reference output pin on the scope to check it's working. Get a ref output pin on scope to check it's working. To check the scope's working. I think we did that last week, didn't we? Could try. Frequency peak to peak. Times 1. Let's go in there. It's almost like my signal generator's playing up, isn't it? But hang on, what am I on here? What was my output? I've got modulation on it. Should have turned the modulation off, maybe. $150. That's no, it's just noise. Okay, if I connect the scope probe directly to it, so I'm connected up with the scope probe now. That's pretty stable at 150 kilohertz. Let's try that 55 megahertz again. I don't like 55 megs. I mean, the scope. And perhaps the signal generator is playing up around that. And I've just got the scope probe connected up to it at the moment. Let's try 50. Well, that's 55 megs. It is reading thereabouts. I mean, it's stuck on my lap. Come on, clip on. Ten megs. So at the end of the day, if I just connect that up from there straight into there, that's no different, because I was connected onto the end of the BNC lead with the scope probe, so it can't be the lead that's a problem. Surely. Yeah. I mean, that's perfectly stable now. Let's try 55 megs again. Well, I don't know. That's a mystery to me. So this looks like a signal generator is fine. That's pretty damn stable and accurate. 56 megs. Yeah. 30. 10. 70. How strange. Now I'm confused. Stephen. It's Steve. I'm direct signal gen direct to scope at the moment, but that wasn't doing that just now. We were connected direct to scope just now. It's all over the shop. Bizarre. Okay. So let me get me bearings here. So if we connect that to there now, that's our that's got to go from there to there. And we were having problems. So if I leave it at 70 megs a minute, let's see if this picks up about 70 megs then. Perhaps it's just having a funny 5 minutes. Connect the ground. And see, it's not picking it up. So you think that would be picking that 70 megs? I mean, it's picking something up there, isn't it? But it's very low level. I'm chucking 50 millivolts into it, so it's a fairly hefty signal. There is something there, though. It's very ropey. Yeah, it is there, but that ain't great, is it? Maybe it'll act differently on a... Maybe it'll act differently on a radio, I don't know. What's your thoughts, people? Just throw it in the bin? I'm gonna have... What I didn't do was take off some of the... See, I've not even got the ground connected there now, and it's still showing the same signal. I mean, you couldn't adjust anything with that. It's all over the shop. Catch you soon, Aaron. Cheers, mate. I think he does. Could be a ground and shielding frequency issue. The black foam is not conductive. See, Harvey, you could have jinxed that by negging out my foam, couldn't you? The conductive, potentially conductive foam. Or are you just having a laugh again? Am I taking this foam out, Harvey, or are you having a laugh? Because, I mean, that is the sort of stuff that they stick things on, you see. But I couldn't get any conductivity across it on the multimeter. Like, you'd think if that's conductive, it would be 0, wouldn't it? What I didn't do, though, is I didn't cut those... I didn't cut the traces back at all. So we've got a bit of stray capacitance maybe floating around on this board. It's not ideal. So it's conductive foam's coming out now, are we? Just as a test. Conductive foam is now out of the building. No different. I was measuring the frequency there. I've got it set at 70 megs at the moment. The ground doesn't seem to make any difference, which is a bit strange. That's a rubbish signal, isn't it? I mean, that's as high an amplitude as a scope will go. Yeah, that's not a very clean signal at all. Let's try a clip lead on the ground inside. Maybe that BNC's not making a good ground, so let's clip lead from that to the SIG gen. Oh, he says as it drops off the table. That's not made any difference. If anything, it's made it worse. It's like there's no ground connected, you know. I reckon it's that coupling cap you maybe put in, you know, that's the problem. I think it's the coupling cap's the issue. I'm powering the box with the bench power supply at 5 volts, are we? I'm checking that that's getting through a minute. Yeah, so we've definitely got 5 volts coming through. What are we expecting on that FET? Any voltage at all? The gate is 0.2. Source is 0. Drain is 0. So voltage is coming in there. It's going along there into... Hang on. Let me just double check that I've got this wired up right. That's going to be the next thing, isn't it? So we've got a power coming in, going straight into that resistor, which it is, yes. From the resistor, it's going into that cap, which is coming into the output. Yeah, that's correct. The other side of that resistor is going to the hang on. Yeah, I'm wondering if I got this wired up right, you know. We need to do some debugging, I think, maybe. The problem is I can't see the other side of the board. So I believe the traces run that way down. Yeah, they do. Okay. So I'm just having a look on my little board here. So that's our power going in to that resistor. Then through that resistor to that capacitor. And also to the yeah, I'm wondering if I got that FET in the right way around, you know. I'm wondering if I got that FET in the right way around. Rob, you got the caps on again. Drain should not be 0. It's the flux capacitor. Where does the thin white and black cable go to? That's just the connection to the board. So that will be the connection to the set under test, Sharpie, Steve. That's just a BNC. That's the input to the buffer. I think I've got the FET in wrong. So let me just look at the sheet for that again a minute. The sheet, one sheet. So it's gate, source, drain. Gate, source, drain. So the drain, gate, source, drain. Drain is going to there, yes. That is correct. That's connected to there. The gate is connected to the one puff and the one mag. Yeah. Gate. And the source is connected to ground. That is correct. I have got it wired right. Yeah, I've got it wired right. I'm not cracking up, I don't think. I mean, if I put my component tester on that, would that tell me which lead was which? With it in circuit or not? Let's give it a try, can't we? Well, let's go green for gate. No, hang on. It is, yeah, gate. Drain is blue. The source is red. Red is drain. Yeah, that's correct. Green is gate. Yeah. It is right. I'm not cracking up. I don't know, there's loads and loads of info on this. Flipping loads of it, and not a clue what any of it means. Well, I probably would, but I just can't. I'm just doing my head in already. And it's not actually working. I can't understand why. Yeah, no, I am connected up right as far as I can see. What other options have I got? Let's just pop it out, make sure we've got no bridges anywhere. No bridgers. Thanks, Rob. Roast beef. Catch the conclusion. The conclusion will be that it'll be in the next stream, I bet. I've got a clue what the time is. I can hear Mrs. Cruncher moving around downstairs. I don't know what time it is. 25. Oh, that's a little bit of time. Measure the voltage on the drain again, please. Let's connect it back up then, Nick. With no input, Nick. So just sat with 5 volts on it. So the drain is there. 0.23, Nick. And that's the other side of that resistor. So that resistor is 2.4K. So the other side of the resistor is where the drain is. It's connected as per that. Yeah, no input. So I'm measuring it here. So I've got 0.2 here and I've got 5 volts here. Thanks for subscribing. Constant Bertocci. I don't know if that's how you pronounce it. Apologies for the mullered pronouncement. Let's just turn this light here back on. That's a bit better. That's a bit brighter. Looks like I'm in the dungeon somewhere. What's the voltage across the drain resistor? The voltage across the drain resistor. 4.79, Ben. I think I'm going to have to probably bang this one down my neck, aren't I, Let? I'm going to have to go in with John's daft old fart beer, I think. Don't you? I think I need that because it says up at the top here, look, as daft as a brush. Daft old fart. Cheers, John, if you're watching. I have got a board here of John's as well to sort out for him, so I must get that done. There's so many things to do. I was hoping this would be the conclusion today and we could get Clints radio up and running, but again, it doesn't look like it. Could verify the 2.4K is a 2.4K. I think we had the same sort of readings previously, and I think I had a 2.2K, was there, or something in before? So these are the 2.4Ks that I bought in. 2K4, so let's just verify that they are, and they haven't stitched me up with a 2.4 meg. Again, let's just null that out. Yeah, 2.4K, absolutely bang on the button. They're 1%ers as well. So yeah, no problem with the resistor. We could check the 1 meg is correct. Let's just pop that in there. Let's try the 1 meg, see if that'll measure in circuit. Yeah, that's definitely 1 meg resistor. See, the only thing different that we got in this one that we haven't got in the set is that capacitor underneath, but that surely that wouldn't do anything to it, would it? You haven't stitched me up with a dodgy cap, have you, in underneath? A dodgy cap situation. Oh, the one in circuit, okay. So we should be able to measure that between there and there. Yeah, 2.4K. Sorted, Joe. What's a brush? Daft as a brush. Whoa. I mean, I can show you various brushes if you want. Joe, there's a brush there, look. So really, I'm as daft as that brush. The brush is pretty daft, isn't it? Really, it can't do a lot. Or there's that's a brush as well. That's a brush. You not heard that saying before, Joe? Daft as a brush. It's another English, British saying, isn't it? We got lots of rubbish sayings. Anyway, cheers. Daft as a brush. Cheers, Aston. Christmas late at your son's. I haven't done Christmas at my brother's yet. Oh, you get it? We're not getting very far. I think we need to get this off in the post to Nick. I think this needs to get posted up to Nick. Because I think he's the only man. He is the construction king. The king of construction. The only way to get that voltage drop is for the FET to be turned hard on. Which voltage drop is that, Rob? The voltage drop against the, across the resistor, you mean? FET is hard on. Yeah, across the resistor. Well, have a go, Nick. Have a go. I mean, if you can build it and it works, then there's got to be something wrong with mine, isn't there? Either something wrong with my FET, but it seems to be measuring okay as a FET. It knows it's a FET. It is the correct one according to this schematic. I mean, it's a 2SK193-E. Is mine the -E version? No, it's just a 2SK193. It's got P2Y. But that is the correct FET. I think we had this problem before when I cobbled one together with another FET. If you remember, we still had the same issues. It's almost like this circuit doesn't actually work. So we've got power going from there to there, which is correct. Power goes in from there, in through the 2.4K, back out of the 2.4K, and then it's in between the junction of that and that, which is correct. The center pin is the source, and that is connected to ground, together with the 1 meg, and that's connected to the ground of the BNC. And it's connected to the ground of the power supply. Then the gate is connected one side of that resistor, which is to ground, the 1 meg. Then it goes to the 1 picofarad cap, and then to the center pin of the BNC. It is wired correctly. I keep looking at it thinking it's not wired right, but the only difference is that cap. But I can't see that causing an issue, because that's just literally costs a positive and negative, isn't it, really? That's not gonna do anything wrong. Let's turn some of this stuff that's humming in the background off. I've just measured that FET in circuit and it's right, Bob. Check drain to source with no power. What do you mean on the ohms range? A drain to source, so gate drain source. Well, that's just going to read that 1 meg resistor. Yeah, because gate to source is has got that 1 meg resistor in series to it. So it's going to read 1 meg, isn't it? Yeah, I did buy more than one. 2SK193 all the way from China on a fairly slow boat, but it did get here. The stuff is getting here a lot quicker from China than it used to, I can tell you that. I don't know why, but it is. Let's grab another one out then. So according to the spec sheet, which is here, it is, if you're looking at it, which way up is this, for God's sake? That's the front face looking that way. So yeah, it's gate, drain and source going left to right from the front face. So this is a front face. Gate, source and drain. So we'll go green for gate, blue for source, and red for drain. Right, let's get back to the bench. I mean, it could be fake, I suppose, couldn't they? But there is, so green is gate, blue is the source, and red is the drain. Yep, so the pinout is correct on it. I don't know what all this VGS minus 1.29 volts. If you can see all that business in the screen, let's get you right in the guts of it. Am I in the way here? I can't see. What's going on? No, I'm not. So I scroll down through. As I say, I don't know anything about FETs, to be fair. I'm not going to say I do. It looks like there's not a lot of voltage to switch it on and off. What on earth does all this stuff mean? What does it all mean? There's loads of it, look. There's loads of it coming up. Flipping heck. So if you've got a data sheet, you could pretty much sort that right out. And then back to the start. No, it is pinned out correct, but gate. Source and drain, yeah, it is pinned out and it is correct in the circuit as well. So yeah, there you are. That's your little trip into the guts of a NFET. N-channel FET. Whew, I've got a headache after that. Yeah, I did put the peak tester on it. On the spec sheet, does it say what voltage it needs to turn on? Gate to source cut-off voltage minus 2.5 volts. Zero gate voltage drain current. Forward transfer admittance. Power gain, noise figure. If any of that means anything to you, I don't know. Which it doesn't. Which is the one that's saying what switches it on then? The voltage to switch it on. Minus 2 volts to turn it off. Potable. You can drink it, yeah. Not sure what the fettle that means. It means fettle to me, David. That's all I can say. It's absolutely fettle. Absolutely sweet fettle. Afternoon, Gavin. How are you, mate? You've been working. Oh dear, working on a Sunday. I haven't got a clue, Tim. I know nothing. VGS is the voltage to switch it, but some FETs are on until you turn them, or on until you turn them on. On until you turn them on. I think my head's, the top of my head's going to go, in a minute it's just going to blow completely off. It's going to go completely off. So we built it. We came, we saw, we built it. But no go. No go. And I mean the tracks are going the right way. Let's just mark them in with a pen. Probably won't be able to find a pen now. So yeah, the tracks are going sort of that way. They're going long ways. So I sort of checked and double checked, and my wiring is all bang on. Absolutely perfecto. Nice little device, isn't it? I wonder, I mean, what we didn't check is if we put the lid on, because the whole thing about it is being screened, isn't it? We didn't check it with the lid on. Would that make a difference? Just a thought. I mean, that's the old idea of having the little box in it, so as you can pop the lid on and away you go. Ground to the case is good, yeah. Yeah, I'm grounded on this tab here, look, Christian. So I've got a lock washer in there, straight down into the ground on the board. So this is all grounded. I suppose I could check it, couldn't I, on the ohm meter, but so what, these leads, they do seem to do some strange things sometimes. It's almost like I've got a bit of a break on them or something. So I wiggle them around, I can get the yeah. Yeah, I've got a good ground there. There's no problem with the ground. FETs will do now. John, how are you? Perf board. What did you say ages ago, Rolf? That I've lost the plot? John saying the purple might have high capacitance between the pads approaching the gate threshold. Oh, you said that ages ago, did you? Glass of Fireball cinnamon. It's already forced you to drink a large glass of wine. Oh dear. Negative power supply to BNC ground. That is correct. Yeah, I have got that. Anthony, is that not right? I mean, it doesn't show the negative supply anywhere in here. I've only got the positive, and we've got this ground here showing on the diagram, which is the ground to the case. And I mean, my ground is connected into this rail here. So my ground from the power supply is connected into this line here. It's all Nick's fault. Oh dear. No need for more leads, Rob, I don't think. Well, as I say, that doesn't look like it's going to do anything, does it? I have got some stray capacitance on it. I'm sure perf board isn't ideal for it. Don't know what else to try, really. I can pop it back up and pull off some of the tracks, which I was going to do anyway, but I forgot to do that. I could try it with the lid on it. I expect it is. Please check the ohms on what? The negative power supply to BNC ground. Oh, I see what you're saying. Right, okay. Let's do that. Negative power supply to BNC ground. Make sure those leads are still nulled out. No, they're not. See if I wiggle the leads, look. It sort of changes. I don't know why. So negative power supply to the BNC ground is a dead short, pretty much. So we've got two other things we can try. But it seems strange, you know, the other one that I did last time we looked at this, which was a few weeks ago now, will that come up enough to do it? No, I'm just going to have to pull that off as well. Yeah, it was doing exactly the same. It was a different FET. We didn't have the right resistors and all the rest of it, which I thought was probably part of the issue, but maybe it wasn't. So there is going to be some stray capacitance about, and I was going to chop the board around, but I didn't. And it's a bit of a pig's ear in underneath, as it usually is with Wera board. So stray capacitance. This is our input, so really all of that trace there needs to come off. So if I get the scalpel, cut across there, I should be able to scrape this trace completely off, or break it anyway. Okay, that's gone. I suppose any pads, I mean this pad here we're not using at all, the center one. So really that can come completely off. It's going to be probably easier if I just take this off and take the board completely out. This extra cap, where is it being put on the circuit? The extra cap was put exactly where I was said, that was on the between the source and ground, I think, wasn't it? Was it? Where is it? Where's my picture? Where's my picture gone? So that's where that extra cap's gone. In there. So between the 5 volts and the ground. But as close to the source as possible. So it's pretty much gone from there to there. Are we saying that's wrong now? That's the only thing I've done different. Stop messing around with the low-level signals and stick a 5-volt AC signal into its input. No, you're all confusing me still. So I'm going to remove any excess copper that I can see. Hopefully I don't cut any tracks that I shouldn't do. Hi Stuart. There is quite a write-up in vintage radio forums that this probe circuit is a little suspect of design. Ah, Stuart. Thanks for that, mate. That's on the vintage radio forums, is it? Why on earth would Sony repeat it in so many manuals if it was wrong? I suppose it might be some special tool that they used to provide that was manufactured by angels or something, maybe. So I'm just working away at this board, being very careful that I don't cut my fingers off, because I am using a scalpel just to get rid of any excess pads that we don't need here. Probably total misuse of a scalpel, really, isn't it? Probably better off with my Stanley knife here. Yeah, it's actually a bit easier to do it with that. There's nothing in that line either, so you've got two lines totally unused there. Be better off with the Dremel, really. Dremel the bejesus out of it. It's like peeling spuds, isn't it? Peeling teddies. Loads of capacitance. Loads. Away with the capacitors. So this is going to be the final test, and that is to remove all the strips that we don't need, stick the lid on and try it one more time. It could be that all that noise we were seeing was caused by the fact that the lid wasn't on. Just picking up all my LEDs and all the rest of it. Now we're really cleaning it out now. A good turnout, this is it. Good turnout. I might need a whiskey after this, I'll tell you. It's making my fingers sore, this. Use the force. You've not read it in detail. Fiddly to get working. All right, okay. We've certainly found that out. Is that on the Vintage Radio Forum, Stuart? It might need to be sprinkled with holy water or something, perhaps. Maybe that's the thing. Okay, that's got all of that off. Now there's a whole load underneath there that I can't get at because of this cap. But saying that, no, I can't have most of that in. Always cut away from yourself, people. Away with these stray capacitants, you beastie. I sounded a bit Scottish there, let's sound, didn't I? Apologies. Nearly there. If it's a finicky circuit, you know, this could be, if we're dealing with like very low voltages, this could be make or break, couldn't it really, I suppose? Right, that's it. Where are we? No, we're there. Everything is ripped off the back. Probably ripped most of it off the front as well. What's that sticking up through there now? Oh, right, okay, that's okay. Right, so that's got all the stray capacitance gone. I know we're still going to have capacitance between these things. Maybe I should have popped that over to the next trace. But then that's between the source and drain. Let's try that anyway. We've done something different. So, you know. Let's zoom you back out. Let's put this back together and then beat the hell out of it with a stick. A bit like that. Oh, low current feed. Let's connect the monster back up again. Shove it on the IC. Shove it on it. Shove it up it. Get off. What are you doing there? Crazy old thing. Get that one out of the way. Don't need that. Why are you there even? I need some more daft old fart in me a minute. Nice bit of that. So that's instantly blocked my sucker up, that. Instant suck blockage. It's a good solder sucker, but it does get blocked up very easily. Should put a bit of foam back underneath because we know that that's not causing the issue. Just in case. Right, let's have everything connected back up. Let's move everything away from everything else. Move that one away from that one. Let's pop on the liddy on and only goes one way. Anybody got any ideas what I did with the screws? Anyone? Oh, I got them. I've actually got another SW55 in here waiting to be done as well. I was hoping to actually open that one up today, but it doesn't look like we're going to have time now. It's a bit of a shame. It's been waiting. Clints has been holding it up a little bit because Clints came back again. Clints is working now. It wasn't working before, but unfortunately it's not as good as it should be. We are out on the frequency. Now I can fudge it, but it's does need setting up properly, really. A quarter Scots, is she, Ben? Yeah, I'd best not be doing all that imitation. Okay, so power in. Not drawing any current. That on. Scope on. We're going to use the scope to measure the frequency. I forgot which is bloody in and out now, though. Oh, can anybody remember? Goat's ass. I think it's this one is the radio input. Oh, you fool, Graham. See, I was going to print out some nice labels and all sorts to put all over it, and you know, centre pin positive and all the rest of it. But I haven't had time to do any of that because I'm too busy fault finding something that's right in the first place. Yeah, so that is the input there. To the left. So what's right? Or to radio. So that's FQ. Frequency counter, and that's the input. Or radio. Yeah. You don't want one of those, Rob. You're much better than that. Dear. You've got so many to sort. SW55 is not a nice radio to recap, really. Better off doing the 7600, like I said to you ages ago. You bought a 10,000 million caps for it and not done it, Rob. Go for it. Get it done. Get it sorted. Right. So, SIGGEN. What are we doing with the SIGGEN then? We're going to pop our little piddly thing on for the SIGGEN. So I'm going to jam that in again. Jam that up the output. Jam that in the ground. So I've got fairly short leads there. Let's connect this up to the scope. See, we've got no difference at all. That absolutely diddly squat different. Let's show you. Let's turn that light off again. Still got a really noisy signal. I mean, I've got the scope, so let's just do it to 55 megs. So it is reading 55, but look how noisy that is. What is going on there? So wiggle the leads, making no difference at all. Let's try with a scope probe directly. But then someone's saying that scope probe's gonna scope the actual BNC on the body, then see if that's, if I can get let's probe the actual bodies, put it on ×1. So it's totally cut the lead out and just put a scope probe. Well, no, it's going to put capacitance in, but this is the output, not the input. That's worse. Is it worse? Yeah, dear oh dear. It's even worse. Doesn't appear to be doing a lot, does it? I've got the case jammed underneath it as well to give it a bit of extra grounding. It's just not stable at all, is it? It's all over the place. Right, what are we talking about? Put some foam under a bottom. So you need quite a high input voltage to drive it. Well, I'd say at the moment I'm on 50 millivolts. I can go to 100 millivolts. So it's a bit more stable at 100 millivolts, look. 200 millivolts is, no, can't go. 100 millivolts is the highest I can go. So it's more stable at 100 millivolts. Still noisy, but that, I mean, that could be anything. The scope itself is noisy. Could be my on-air thing, couldn't it? It could be that battery charger there. causing problems. Oh, could be my little neon light causing problems. No, still noisy. Would help if I was straight on with it, really. Let's turn off some of the other lights, see if that makes any difference. You can see the screen a lot better, but I can't see nothing in here now. I'm blind. I'm blind. So 100 millivolts is the highest my SIGGEN will go there. Pretty. It's pretty. Alright, let's turn all my lights back on. Doesn't make a blind bit of difference, really, does it? Could have my on air light on from Bruv. Oh well, it was worth a try, wasn't it? But close but no cigar. It's definitely conductive foam, Anthony. Turn up the wick on the gen this time. Try Paul's power off test. What's Paul's power off test? What is the power off test, Paul? Consider trying it on the Sony receiver. We definitely have not got time to do that today, unfortunately. Unfortunately, we have not got time to do that today, sadly, because that's the whole point of it. But close but no cigar. What's the power off test though, Paul? I'm not really sure what the power off test meant. Oh, gen active, all hooked up, kill power to buffer circuit, observe scope. Right, okay, we'll do that. I've just turned everything back off again, but we'll do it. We'll do it. Oh, actually, the power leader come out there. Oh, no, that's the wrong one. That's okay. I thought the power leader come out then for a minute. Okay. Power off test, here we come then. Let's get rid of that light. Powering off, I'm just going to pull the plug. Now. Power going back on. Now. Power off test, done. Bob's off. Cheers, Bob. Have a good one, mate. So that does prove that something's working, doesn't it? Something somewhere. get some more daft old fart down my neck a minute. See, it works. It's a hell of a signal to put in though, isn't it? How am I going to measure? I mean, are we saying that the output from the Sony is going to be around that amplitude? Is it going to be measurable on a frequency counter? I mean, let's try it. Where's my frequency counter gone? Where did I throw that one to? Let's take it back off of that one then. Let's try it on the frequency counter now. I've got it wound up full tilt and we've done all the other nastiness to it. See what this one reads now. Haha, nothing. You don't read nothing. Wait. What's going on here? Oh, hang on. It's almost like me holding the wires, putting some capacitance into it. There's other wires tangled around it, which is not helping, I don't think. Right. See, I had... It sort of goes 55 dead sometimes. What is going on here? Is it a dodgy wire? Let's just try a scope probe again. I mean, that's reading okay. There's no problem according to my thingamajiggery. He's not reading anything on the with scope probe, nothing. I've really got to shoot off people, but let's just poke some wire in the holes. Poke some wire in the hole a minute. No, thinner. There. Let's just connect the grounds together. No, so I'm going directly into it now. It's like it's intermittent. No, I just tried going directly from this directly into the unit here, but that don't seem to make no difference either. Oh well. It was good while it lasted. But I'll need to get it. I will stick it on the radio in the week. If I get a chance, I will stick it on the radio in the week. And we'll see if that makes any difference at all. Camera's gone dark now as well. Still on air. Let's just catch up with the necessary then. Did you get the E version of the FET? I don't know, I didn't, Stuart. I think I've got the P version, not the E version. Has it got to be the E version, has it? That'll be the next thing, won't it? Oh, 2 to 3 volts. Okay, Derek. Okay. Access Area 6. Welcome, mate. You are late. Yes. The amplifier row 1 volt. The idea of the buffer to stop the test gear loading the circuit. Alright, I will try it then, Rob. That'll be the test. I'll try it. Nick's threatening to build one if the weather gets warmer. You're also skeptical that it's a real 2SK193 as they seem to be unobtainium. Picking up mains from your finger, if you look at the circuit output on the scope, you'll see that 5 volt square wave when you touch it. Derek agrees with Rob. Should be swimming in spare BNC cables. I haven't. It's not something I use a lot of, to be honest. I just used to use it for working on the CB radios, just connecting up the test equipment, but let's so this is what we're talking about, the clarification or classification of IDDS. Now, I believe I've got a P, which is 1.5 to 3. They're saying to use an E, 0.75 to 1.5. So yeah, mine is P. Will that make a difference? I don't know. But I'll be interested to read the forum thinkings on that, Stuart. Cheers, Rob. Build it without the Wera board. Yeah, there's lots of, well, there's not a lot of things I can try now, really. I can certainly try it on the radio if it's got a heftier signal. But if you recollect, we did try the other one I had on the radio with no effect, but Oh, hello, two of me. Do you want two of me? Get off. Get off. Whoo-hoo. So there you are. I haven't got an E, I've got a P. I have got some more here somewhere. It's showing that I've got another couple that I bought in, but I don't know, they might be different. Yeah, I don't know, Anthony. Well, I hope you've enjoyed that fumbling around today. It's been interesting to build it. It's just, as I say, I will get it on the radio in the week and see if it makes any difference. But, you know, I might just hang that from the light as an ornament. Wear it as an earring, couldn't I? Huh? Oh dear. Well, it was a good effort. It was a good effort. The theory was good. The theory was good. And it looks nice. It looks pretty anyway, doesn't it? It does look nice. A finger test. What do you mean the finger? And Rob's saying add a 27k resistor between source and ground. Yeah. See you next week with, well, I must get, I've got another SW55 I've got to recap. Chap's been chasing me for a little while now, so I must get that done. It did come in after Clints, to be fair, but Clints' issue is frequency. It is working, but it's just not stable. It's not on frequency as it should be, which is a pain. Tracer. $1.2K between the source and ground. Oh, you mean separate the source from ground with a resistor? I'll stick your finger on the input and see if there's a 50 Hz square wave on the output using the scope. Okay. Learn from failing. I know. Well, you know, it's live. It's live. We built it live. It failed. Why did it fail? Until we actually get it physically on the radio, it's difficult to say 100% whether it's any good or not. So until then, fingers crossed. You never know. It might be good. We might be panicking about absolutely nothing. But it's all Nick's fault for telling me to try it first before trying it on the radio. I should have gone straight for the radio, but then we didn't really want to kill the radio if there was something wrong with it, did we? Right, there we go, people. Good to have you all on board today. Thanks again very much for the super chats and the tips. All appreciated, and I'll catch up with you next Sunday, if not before. Bye for now.